So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware. So my subject is physics. We are in class 7th. Our ongoing last chapter, gravitation. And today we are entering into the third session. So far we completed 2 classes in understanding what is gravitation and what is gravity. So what we learned is first class, what is gravity, what is gravitational force, right? Then what is Newton's laws, which explains about the factors influencing the gravitation. Newton's law of gravitation, that is about G, universal gravitational law or constant. Universal gravitational constant, which is obtained from Newton's gravitational law. Then we introduced about the even small g also, that is acceleration due to gravity. This we introduced in the last class, and today we are continuing where we left in the last class about the acceleration due to gravity, on what factors acceleration due to gravity depends, right? How it changes from place to place, how it changes from planet to planet, the value. Whereas universal gravitational law is constant, you know, this is a constant everywhere in the universe, whose value is 6.67 into 10 power minus 11, right? G value. But small g value changes. Minus 11 Newton meter square by kg square. It is a constant everywhere and anywhere in the universe. Whereas the small g value changes from place to place. It means constant on surface. When you go to the moon, it is different. When you go to sun, it is different. When you go to Jupiter, it is different. Because their masses and distance changes. Right? That we'll discuss today in deep. How this G value changes with change in the surroundings. Right? So that is our today's topic about the acceleration due to gravity and factors affecting the acceleration due to gravity, right? Okay, so we'll move forward. So this is what we learn about gravitation, the force of Earth. The force of Earth is called gravitation, and also called as gravity. Whenever a body, when you are dropping or projecting, what happened? Always body is attracted towards the center of Earth. Such a force is called gravitational force, which is a non-contact force. So this gravitational force mainly depends on mass of the bodies and distance between the bodies. You can see on the picture. So based on that only, Newton explained about the Newton's gravitational law. So what he says that every body in the universe attracts every other body with a force called gravitational force. But every body in the universe attracts every other body with a force called gravitational force, which is directly proportional to product of their masses and inversely proportional to square of the distance between them. From that we got the Newton's equation like this. F is equal to G mm. F is equal to G into, we can write m1 m2 by r square, or you can consider the m as mm also, mm by r square. The capital M is the mass of the earth, small m is the mass of the stone, because very small in compared to the earth. So this is called Newton's law of gravitation, where this G introduced by the Newton is nothing but universal constant, right? Newton's universal law, universal constant. So this constant, because it's a constant, it has its own value as well as units. So you can have G is equal to, you can take everything this side, right? It becomes FR square by M1, M2 or MM. G value, G is equal to, where M is the force, F is the force, gravitational force, R is the radius of the earth, M is the mass of the earth, M is the mass of the body. By substituting the value, you get the value of G is equal to 6.67 into 10 power minus 11 Newton meter square by kg square. Why? Because F is Newton, distance is meters, distance square is meter square, mass into mass, kg into kg, kg square. Okay, this is the capital G. No confusion. This is about the capital G, whose value is constant everywhere in the universe, whether it is Earth or Moon or Sun or Jupiter or Mars. Wherever you go, this value remains unchanged. That's why it's called universal constant. Next is another important one we are discussing is acceleration due to gravity. Acceleration due to gravity, that is small g. So this is denoted by small g. The difference is that is capital G, this is small g. Capital G is constant. So what is acceleration? Acceleration is nothing but rate of change of velocity. For example, see. So this is Earth, right? You are dropping a body from here. So just dropping. So what happens is body will come and reach the Earth with some acceleration, that is A. A is equal to G. We can call it as, when you are dropping a body, its velocity is 0, but still it accelerates and touches the ground. Why it is accelerating? Because of the gravitational pull of the Earth. Such an acceleration produced in a freely falling body is called free fall body. We are not applying any force. Acceleration produced in free falling body due to gravitational pull of the Earth. Just like apple falling from the tree, which is the first observation made by Newton, right? Okay. So from that we can conclude that there is an acceleration is there in the body, which is called acceleration due to gravity. Right. So this acceleration due to gravity, so we can hear factors affecting the acceleration due to gravity. On what factors? So the G value, see, when you see the G value on Earth, if you see on Earth, surface of the Earth, which is 9.8 meter per second square. Right. Try to understand. Similar, same G value at equator. Equator, when you go to the center of the Earth, it is 0. So Earth is nothing but poles, is maximum at poles, 0 at equator. Means when you are going from surface to the equator, equator horizontal line, which center of the Earth, when you come, G value becomes 0. So G value is maximum at poles, minimum at equator. That reason we'll discuss later. Is there clearly? Then when you go to the G value on Moon, it is 1.67 meter per second square, which is 1/6 of the G of Earth. G of Moon is 1/6 of the G of Earth, which is 1.67 meter per second square. 9.8, 1.67. See, suppose you weighted yourself on Earth as 60 kg. When you go to Moon, your weight will become 10 kg only. You feel like that. You feel that you are becoming weightless, but it won't happen because of the G value. The value of the weight also changes. Right? Same when you see the same G on Jupiter, if you go, because Jupiter is have more mass than the Earth, whereas Sun is less mass. Because of less mass, we can find the G value is less for the Moon. But when you go to the, just a minute, when you go to Mars, the Jupiter, so G on Jupiter, if you see, it is around 29 meter per second square, almost 3 times more than the Earth. Similarly, G on Sun, 27.4 meter per second square. Observe here, the value of G changes with the change in the planets. Planet to planet different because change in the mass. Right? Whereas On surface of earth, it is 9.8. But when you go to the deep into the earth, the value becomes 9.8 to 0 also when it reaches the center of the earth, that is equator. Similarly, when you go to the height also, the value of G decreases. So there are so many factors are there where the value of G decreases. That factors we'll discuss now. So before that, let me show you one video on this same, what is acceleration and what is the factors influencing the gravity. Later, we'll go for the explanation, right? Just observe the very little big video which contains the complete information about the acceleration and acceleration due to gravity,
which is denoted by G, and factors affecting the G. And this G is a small g, not capital G. Capital G is for gravitational constant, but this is small g is acceleration due to gravity. What is it? Acceleration due to gravity can be defined like this. Acceleration developed on a freely falling body due to the gravity of the earth is called acceleration due to gravity. Look at this word, freely falling body. It means there is no any
freely falling body, which is falling freely from our hand. Just without any force, you are dropping. Means velocity is 0, but still it is accelerating. How? Because of the gravitational pull.
Resistance. And acceleration due to gravity is possible only in vacuum. In air, the motion of the body will be obstructed by the air. Okay, its average value is 9.8 meter per second square. I mean, we can understand this very clearly like this. If a body is dropped from certain height, it will certainly fall in a straight line. And first, its velocity will be 0 when it is not dropped. And when it is dropped exactly after 1 second, its velocity becomes 9.8 meter per second. And at the end of second, its velocity increases to 19.6 meter per second. And at the end of third second, its velocity increases to 29.4 meter per second. Every second, velocity is increasing and increasing and increasing. And this increment is of 9.8 meter per second. Look at this. In first second, increment is 9.8. In second also, 19.6 minus 9.8 becomes 9.8 meter per second. Here also 29.4 minus 19.6 gives 9.8 meter per second. Every second velocity goes on increasing, and this increment is by 9.8 meter per second. Because of less velocity in first second, it covers less distance, but in second it covers more distance because of more velocity, and in third second it covers more distance. Since velocity is increasing, that's why distance covered in every second will also be increasing, and its acceleration will be 9.8 meter per second square. This is acceleration due to gravity. I want to tell you another matter also. When a body is dropped from very great height, at this time also it falls down in a straight line, but it falls in such a way that every second its velocity goes on increasing this way, and it covers more and more distance. In first second, if it covers this distance, second more, third second more, because its velocity is increasing and increasing. The reason is very simple, because it is pulled by the gravity of the earth. Earth pulls it towards its center, and because of this gravity force of the earth, the body accelerates. Acceleration never produces without the force, and gravity force is responsible to produce acceleration on this body. But when its speed increases in the air, then air resistance also increases, and air resistance acts in opposite direction, which is against the motion of the body. So air resistance goes on increasing due to the increase of the velocity of the falling body, and a condition comes when air resistance neutralizes the gravity. When air resistance is neutralized by gravity, then the body begins to fall with uniform velocity, not acceleration, because force is seized by air resistance. That's why now it falls with uniform velocity. And so we can say that there is two types of motion. At the beginning, the body falls with acceleration due to gravity, but when air resistance neutralizes the gravity, then it falls with uniform velocity. Now let's talk about the factors which affects the value of g, small g. Number 1, the radius of the Earth. Earth is flattened at pole and bulged at equator. That's why its radius is different in different place. Polar radius is less, equatorial radius is more, and its radius is different in different places, and accordingly value of G also varies from place to place. We'll talk in detail about the same later. G depends upon height from the surface of the Earth. The height from the surface of the Earth decreases the acceleration due to gravity. Value of G becomes less.
Height from the surface.
Depth from the surface of the Earth. As we go to the depth of the Earth from the surface, let's say at this place, then the acceleration due to gravity at this place is less than the surface. This is very interesting. When we go to height, G decreases. When we go inside the Earth, G decreases. This way, G is maximum on the surface of the Earth. Okay, axis rotation of the Earth. Earth is rotating like this in its own axis. Because of this rotation, the value of G is less. Later, we'll discuss about this also. Okay, let's go to...
So these are the 4 important factors which affects the value of G. Small g, right? Small g is on surface of Earth, it is maximum. Either when you go to the height or when you go to the depth or due to the rotation of the Earth, right? Due to the distance from the Earth, that is radius. Also the value of G changes, right?
Another part. G is inversely proportional to the square of the radius of the Earth. It is symbolically represented here. We are going to prove this. Acceleration due to gravity depends upon radius of the Earth, first point, and we are going to prove this how it depends upon radius and y square of the radius of the Earth. We can prove this way. Let's say this is Earth and its mass is capital M and its radius is denoted by capital R and the mass of the body lying on its surface is small m. We can say that let capital M be the mass of the Earth, small m be the mass of the body lying on the surface of the Earth, and R is the radius of the Earth, and small g is acceleration due to gravity. Capital G, certainly gravitational constant. Now, according to Newton's law of gravitation, F is equal to G, capital M, small m by R square. The distance between them is R. That's why D square becomes R square. And mass of first body is capital M, second body is small m. That's why capital M and small m is written in the formula. And this is equation number 1. Now we know this also according to Newton's second law of motion, F equal to mg. This is equation number 2. Here we have F and here also F, the same gravitational force acting on the body of mass m is taken here also, and that's why combining equation 1 and 2, what we get, mg is equal to G capital M small m by R square. We can cancel m and m, and the result is G is equal to capital G capital M by R square. But here is a little problem. Capital G and capital M are constant. What it mean? When a body is dropped at pole and the same is if dropped at equator, at this time the capital G remains same. Capital G is constant. It doesn't make any difference to small g. In the same way, when a body is dropped at pole and in equator, then the value of the mass of the Earth remains same. That's why capital G and capital M are not responsible for the variation of small g. Actually, it depends only on the radius of the Earth. So we can say this way, here capital G and capital M are constant and G is so inversely proportional to square of the radius of the Earth.
So understood now? That is the main, because as the radius changes, on surface it is 9.8. When radius decreases, when it is coming towards the equator, due to decrease in radius, the value of G decreases and finally becomes 0 when it reaches the center of the Earth or on equator, right?
I want to tell you about this equation. This equation is very important, which is used to solve the numerical problem also. So why don't we use this equation to solve one numerical problem? Look at this problem. Mass and radius of Jupiter is given 1.9 into 10 power 27 kg and 71 into 10 power 6 meter respectively. Find the acceleration due to gravity on it and what will be the weight of a man of 75 kg mass on it. First, we have to write the given mass of Jupiter.
What is given here?
capital M is equal to
capital G, we know.
1.9 into 10 power 27 kg, and radius is also given. It is 71 into 10 power 6 meter. Now mass of man M is equal to 75 kg. Acceleration due to gravity small g is equal to what? And there is another question also. Weight of the man W equal to what? Here gravitational constant capital G is missing, that's why we have to write ourselves. Now I am using that equation which is mentioned just before this numerical problem. What is it? Small g is equal to capital G capital M by R square. Now we are taking value. Capital G is 6.67 into 10 power minus 11. Capital M is 1.9 into 10 power 27. And radius here in place of R we are writing the radius 71 into 10 to the power 6, and radius is square, that's why square is here. In second step, in numerator the same, but in denominator 71 into 10 to the power 6 whole square means we can write 71 into 10 to the power 6 twice, and that's why I am writing the same. And 6.67 and 1.9 when multiplied, then we'll have 12.673. Number interact with number, and 10 power of 10 interact with power of 10. That's why 10 to the power minus 11, and here 10 to the power 27, same base. That's why the power can be added or subtracted. Minus 11 plus 27. In denominator 71 into 71 gives 5041, and 10 to the power 6 plus 10 to the power 6 is 10 to the power 12. Now next step is we have to divide 12.673 by a big number 5041. When we divide, we will get this value, and 10 to the power 27 minus 11 is 10 to the power 16, and 10 to the power 12 remains same. Now I'm going to take this 10 to the power 12 in numerator. Now we'll have 0.002513 into 10 to the power 16 minus 12, because this power when goes up it becomes 10 to the power minus 12, and 16 minus 12 becomes 4. And in next step I'm writing this. Now in this step, what we are going to do, we have to multiply this with 10 to the power 4. 10 to the power 4 means 10,000. When 10,000 multiplies this very small number, then we'll have 25.14139. 25.139. And if 9 is removed, then we'll have 1 in second digit after decimal point, 25.14 meter per second square. Therefore, acceleration due to gravity is 25.14 meter per second square.
So
now, numerical is not finished because another part of the question is left. Again, we can say that W...
Right. Anyway, it's a very big one. So what we learn from this is the value of G, on what factors the G value is influenced or is affected. There are factors like height. So G value is different in different places, small g value, as you have seen on Earth or Jupiter or Mars, based on their mass, radius, it changes. So even height changes the value of G, and depth also changes the value of G, right? Then radius also changes the value of G. And fourth one is rotation of the Earth. This will come across in higher classes, right? Rotation of Earth. And even surroundings also, surrounding atmosphere. Like for example, the value of G on surface of the Earth in Hyderabad is different when compared to the California. Why? Because there is the surroundings are different. Here it is very hot, there may be very cold. That coldness, hotness, dust, pollution free, everything may affect the value of G slightly, not much. There won't be much change. 9.8 may become 9.9. or 9.7. So that is the fifth factor, general factor. Remaining all the direct mathematical factors are 4 are there. When you go to the height from the surface of the Earth, the value decreases from 9.8 to up to certain height becomes 0 also. Similarly, depth, when you go to the depth also, along with the radius of the Earth, when you reach the equator at the center of the Earth, the value becomes 0. Means the 9.8 becomes 0 means the value is decreasing. Similarly, radius, as the radius increases from Sun to the Earth, radius is different when compared to Sun to the Jupiter. So because of change of the radius also, the value of G, what he explained here, because G is equal to Gm by R square. Here G value constant, mass is constant. I said mass of Earth or mass of Jupiter or mass of Mars, anything is constant. So only radius changes. So radius directly affects the value of G. Like this, all are the factors which affects the value of G in a life, right? Very, very important. So G is nothing but small g, acceleration due to gravity. Even you can find the value also. How you get 9.8 means you can substitute on surface of Earth means you can substitute the mass of the Earth and radius of the Earth d. He has done here. So where see inversely proportional over z. This formula you got na. So g value is there. Mass of the Earth is there given 5.98 into 10 power 24 kg, and radius of the Earth this. If you substitute all these three values, we'll get the g value as 9.8. That is the g value on Earth. So when you know the mass of the Earth, radius of the Earth, of course, g value is constant, capital G. We can get the g small g on the surface of the Earth as 9.8. But when you see the moon, g on moon, same mass of the moon, so it is 7.4 in 10 power 22, which is less than the Earth. Earth is 24. And radius of the moon, 1.74 10 power 6. Right, it's also less than the Earth. And of course, G value is constant. When you substitute G on moon, same formula. So what we are getting G on moon is 1.6, which is 6 times less than the. So when you divide here, you can get 1 by 6. So 1 by 6 of G on Earth. As because our weight depends only on G value, our weight also decreases 6 times when you go to moon. Okay, so the acceleration due to gravity on the surface of the moon is 1 by 6 times the acceleration due to gravity on the surface of the Earth. Right? Clear? It's a clear picture about the what is acceleration due to gravity and what are the various factors affecting the acceleration due to gravity. Here some more examples also given for you. Variation of the G with the shape of Earth. Because you know shape of the Earth is oval, elliptical. See, the acceleration due to gravity G on surface. Okay, on surface of Earth is given by the formula we know. On surface, right? That is on poles. This expression for G is acceleration accelerated by considering Earth as a spherical body. In fact, the Earth is not spherical in the shape of egg, elliptical, we can call it, na? Above the as shown in the figure. So if Earth is a spherical, we can agree this, but Earth is a elliptical. So the equatorial radius, this is more here. Earth is about 21 kilometers longer than the polar radius. So this is called polar radius. This is called equatorial radius. See, this is less than this, or this is more than this, because elliptical shape. Got it or not? Egg shape. You can check egg. When you say surface of the egg, radius is less. Same thing here. So as the radius changes, what happened? As the radius increases, G value decreases. That is the reason why G value becomes 0 on the equatorial due to increase in radius. That's what the explanation is given here. Okay. So what we get? G on pole is greater than G on equator. G on pole maximum when compared to G on equator, or even 0 it is. Maximum and minimum. So G value is maximum at equator and minimum maximum at poles and minimum at equator. Maximum is 9.8, minimum is 0. Okay. There is a very important factor, that is radius. Second, variation of G with the altitude means height. When you go to height, what happens? Again, radius increases. Radius is nothing but from here to here. This is. So when you go to height, suppose you went up to here. So this becomes radius. From center to here, not from here to here. So as the radius increases, again G value decreases. So when you get to height also, the value of G decreases. So like that, when you go to depth, in depth we'll discuss again in the next class. But see, when you go to the depth also, this formula's explanation I'll give tomorrow. When you go to depth also, the value of G decreases and finally becomes 0 also. Okay. Like that, at every point, even when because of rotation of Earth also, the next factor, due to the rotation of, because we know Earth not only revolves around the sun, it spins around itself. So during that spinning also, Due to that spinning also, the value of G changes. That is also one of the important factor for the G. Okay. So that completely about the value of G and factors affecting the G. This is up to synopsis 2. So we'll continue the same thing. I'll give the explanation for the derivation, how the value changes by simple. Only one formula only we have to use. From that formula, you can get the formula for height and depth only. So later, next, after completion of this, we have to enter into the gravity meter is there actually to measure the G value. Gravity meter is the instrument used to measure the change in the value of G. You can hold the meter on the surface and you can move the meter up, slightly decreasing the G value you can measure. Gravity meter. After that, there is a wonderful principle law proposed by Kepler's laws of planetary motion. Just like Newton's laws, there are 3 laws are there explaining about the complete universal structure. Complete the planetary system. The path, the radius, everything explained in each and every law, time period. Okay, that is the last part of this chapter. We'll discuss in the next session. We'll complete in 2 seconds. We are going to complete this chapter and our entire syllabus, right? So, task you can practice the level sheets, worksheets, of which we have completed 2 synopsis we completed. The level 1, level 2 part we complete and put in the notebook and prepare well for the coming examination. 8th test followed by the grand test in the March. Okay. So that's all for today. So thank you all of you. Thank you each and everyone. Have a wonderful day. Thank you.